Welcome to the video lecture series of Logic System Design based on the KTU syllabus. Now I am going to discuss about Kmap. Kmaps are the graphical representation of Boolean expressions which is developed by the famous scientist Carnot. By his name we called it as Kmap or Carnot map. It is developed in 1953. This is used to simplify the Boolean algebraic expressions without using any Boolean laws or theorems. As you know, when you want to simplify the Boolean expression, we used Boolean laws. So that may be difficult when we forego the theorems. So Kmap will help you in these situations. Now we will see how the Kmap used to simplify Boolean expressions, what is the structure of Kmap, and how we are handling the variables in Kmap. As I said earlier, it's a pictorial representation of Boolean functions and one map cell corresponding to a row in the truth table. Also, the one map cell corresponding to a min term or max term in the Boolean expression. We have already studied about min terms and max terms in the last class and map cell corresponding to either min term or max term. Multiple cell areas of the map corresponding to the standard terms. Depending on the number of variables in the Boolean expressions, we can construct different types of Kmaps like 2-variable maps, 3-variable maps and 4-variable maps and so on. So let's move to 2-variable map. 2-variable Kmap have 2 rows and 2 columns, that is 4 cells in the Kmap. Consider this picture. Here there are 2 variables x1, x2. We can represent either x1 in here and x2 here, or x2 here and x1 here. We can represent in 2 ways. And ordering of variables is important for f of x1, x2. X1 is the row and x2 is the column. And we can also represent x1 is a column and x2 is a row. And cell 0 represents x1 dash x2 dash. That means this is the cell 0. We can represent it as m0. And this is the in this column we can save 0 0. The value is 0 0 depending on the values of rows and columns. Here the value is 0 and here the value is 0. So this column represents this cell represents the value 0 0. So we can convert this value into the variable form x1 bar x2 bar. And cell 1 represents x1 bar x2. That means this is the cell 1 and the value for this cell is row wise 0 and column wise 1. So 0 1 is the value for this column. So we can represent it as a x1 bar x2. Okay. If a minterm is present in the function, then a1 is placed in the corresponding cell. Here when we write a, so we can assume that there is a minterm present in this cell. This is the meaning of the sentence. And please note that any two adjacent cells in the map differ only one variable. Two adjacent cells in the map differ only by one variable, which appears complemented in one cell and uncomplemented in the other. For example, m0 is equal to x dash is adjacent to m1, right? So m1 means x1 dash x2. Here only one variable x2 is complemented. And m2 is equal to x1 x2. So here only one variable is complemented. Consider this example. F of x1 comma x2 is equal to x1 bar x2 bar plus x1 bar x2 plus x1 x2 bar. Here we use two variables x1 and x2. So we have to use two variable Kmap for simplifying this expression. So we can represent this expression in terms of minterms like this: m0 x1 bar x2 represent as m0 plus here this variable m1 plus m2, and we can represent this minterms in the Kmap like this. First of all, write a Kmap with 4 cells and x1 here and x2 here, and 0 1 write 0 1 row wise and column wise. So this cell corresponding to 0 0, this cell corresponding to 0 1, and this cell corresponding to 1 0, and this cell corresponding to 1 1. So for m0 x1 dash x2 dash, that means 0 0. So the 0 0 present in this boolean expression, so we put 1 in the cell 0 0, and the next one is x1 bar x2, that means 0 1. Minterm m1 is equal to 0 1. So 0 1, row wise 0, column wise 1. Here this is the cell for m1, so put 1 here. And next one x1 x2 bar, that means 1 0. For x1 1, for x2 0, so 1 0. This is the cell, second cell, so we put 1 for this cell. So after marking ones using the minterms, we have to group the ones. The group must contains only ones, not zeros. So I here first of all we group like this. From this group we get when we consider this group, the value of x2 is changing 0 and 1. The value of x2 have two values 0 and 1, and the value of x1 is stable. So we put x1 bar for 0, we will put x1 bar here. Value of x2 is not same, so we will not put the value of x2, and this is the minterm, so put plus here. And next group will be this one. For this group x1 is not stable, x1 has 0 and 1. And so what about x2? X2 has only one value 0. So we will write x2 bar. The value of x2 is 0, so we'll write x2 bar. So after simplification we get x1 bar plus x2 bar. Clear? And consider an example: x is equal to apc plus ab bar c. Here there are three variables in the Boolean expression. So we have to use another type of Kmap, that is called three variable Kmap. So from that we can assume that the number of cells can be calculated using the equation 2 raised to n. where n is the number of variables. So when we have three variables, the number of cells is equal to 2 raised to n. That is 2 raised to 3 is equal to 8 cells. When the number of variables in the Boolean expression is 2, then the number of cells is equal to 2 raised to 2. That means 4. So we can use a 2 variable Kmap for solving the Boolean expression with 2 variables. When we have 3 variables in the Boolean expression, we have to use 3 variable map with 2 raised to 3. That means 8 cells. Got the idea? So in the 3 variable map, we have to represent 3 variables like this. Here we can write a variable x, and here we can write 2 variables yz or vice versa. Each cell is adjacent to 3 other cells, left or right or top or bottom or edge wrap. And note that here we will write 0 0, then 0 1 and 1 1, then 1 0. This is not in the order of Boolean values, binary values, right? Just think, just think why we are writing 11 before 10 here. What is the idea behind that? Because when we change a state, we should change only one bit from a state to another state. When we write 1 0 here, there is 2-bit difference between 0 1 and 1 0. That's why we put 1 1 here before 1 0, right? Please note this statement. We will write 1 1 before 1 0 in the 3 variable Kmap. Okay. And like 2 variable Kmap, put ones to represent the presence of min terms in the Boolean expressions. After that, we have to group the ones using the Kmap criteria. That means we can group 1, 2, 4, 8, etc. 2 raised to n cells. Look at this figure. We can group 1 min terms like this, and we can group 2 terms like this horizontally or vertically, and 2 ends like this. And we can group 4 terms as a square like this or horizontally like this, and 2 ends. And this is the example for the simplification of Boolean expression using 3 variable Kmap. Consider an example f of ABC, 3 variables, is equal to a dash c plus abc plus bc dash. Put ones for this each term in the Kmap. For a bar c, so the value of a bar is 0 and c represents 1. So this is 0 and this is 1. So a dash represents 0th row. So we can choose this row. And C means 1. So here this is 0 0 and this is 0 1, and this is the column for 1 1, and this is the column for 1 0. And for C we can choose this column and this column. For these two columns the value of C is 1. So we have to put one here and here. Clear? And for next term ABC, for A1, B1, C1. So this is the row and this is the column. So we put one here for the term ABC, right? Next one is BC dash. So here there is no value for A. So we can choose either 0 or 1. And next one is B. B represented as 1. So here two columns with B is equal to 1. This one and this one. And C dash. C dash means 0. The value of 0 means there is two columns. This one. So we will choose this cell for adding this. So we choose put 1 for this cell. Okay. So we will get 1, 1, 1, 1, 1, 5 ones in our Kmap. And next step, we'll write the result using this Kmap after grouping. So first of all, group 2 ones and group 4 ones. For this group, the value of A is 0 and BC values 0, 1 and 1, 1. And here the value of A is same for these two cells, and also the value of C is same, but the B is changing. So we have to write A dash for 0 and C for 1. So the result will be A dash C. We will not write B here because the value of B is changing. We have different values, two different values. So we want write B here. And next one is this group, 4 cells. In this group, zero, 1, the value of A is different, and the value of BC is 1, 1, 1, 1 and 1, 0. Here only the value of B is same for these cells. So we put B here. So the result will be A dash C plus B. All of you got the idea? This is more examples for you. Just write these examples and try to solve it. If anyone has doubts, please free to contact me. When we have four variables in our Boolean expression, we have to use this four variable Kmap for simplifying the Boolean expressions. The working of this Kmap is like three variable and two variable maps. We can represent two variables in the row wise and two variables column wise, and the value is like for three variable maps 0 0 0 1 1 1 1 0. Just know the order of 1 1 and 1 0 here and also here. There should be one bit change in between two states. That's why we put 1 1 here before 1 0. Hope all of you understand about the idea behind this. This is the one example for simplifying the uh, four variable Kmap. Um, uh, Consider this example A, B, C, D, four variables, 0, 1, 2 like this. First of all, we put ones corresponding cells using the this function, and in the second step we have to group these functions once, group these ones like this, and uh, like solving the three variable Kmap, we get c dash plus b dash t dash plus a dash bt. For solving the Kmap, we will put the variables for 0 the complemented one, and for 1 the uncomplemented variables in the result as a Boolean expression, and also check the states of the variables, whether it is different or same. When the states of the variables is same, we can put here as a result. When it is 0, we put the variable as a complemented, like c dash a dash b dash, or when it is 1, we can put as a uncomplement variable like a b c. This is the example for four variable Kmap solving, and hope you understand about Kmap. Do lots of exercise and examples using the Kmap to solve the Boolean expressions. Hope you understand about the Kmap. If anyone has any queries about Kmap and the simplification method, contact me. Thank you.